So it's this brief session will be about some issues some of our students already know, and maybe some aspects they don't know yet. And the main idea is to show other interested students or people what we are doing and how the small things which we are doing here can fit into a big picture. No? So, yeah, this is my name, and I'm working here, let's say, supported by an institution of the German government, which is in reality it's some kind of a foundation of the German research institutions and universities, no? The DART. And we are more or less the people who are here for the DART. In this kind of position, it's only myself, and then there are some other lecturers. But we are supported here by the German by the German Foreign Office, let's say, by the Ministry of Foreign Affairs of Germany. So it's a distinct kind of cooperation, a distinct kind of international policy support, which is given to many countries. And here in Georgia, in this case, it's my position, which is supporting a little bit education in environmental sciences, natural and forest resources, especially in my case forestry, because that's the biggest gap. And I just want to talk a little bit about man and biosphere, and starting from one issue, which is forests. You see here the Caucasus and South Caucasus, and more than a third of it is covered by forests. So it's quite a relevant issue, and but many people don't know so much about it. And I want to show you what we are learning. Yeah, our students know what we are learning. And we will talk a little bit about teaching also and what we are practicing at Iiliauni. And so I was wondering what to present here at this short session, because I didn't know who will come. So we will see. So we will start from the big picture. The big picture is more or less a human civilization. And the Caucasus is a good example for it. So agriculture started, some kind of human advancement civilizations, they just started after the last ice age, more than 10,000 years ago. And some painters imagine this like this. So in the beginning there was some kind of natural ecosystems in different forms, in different shapes, and there were also forests in some areas, and people were starting to develop their activities. And these were agricultural activities in many cases. And you see there was cutting, slashing was a simple instrument which they had. Even plant and animal species became domesticated. And so agriculture evolved, more or less 8,000 years before Christ. And that was also combined with changing the ecosystems. They were not just, let's say, holding livestock on grassland, but they were also practicing agriculture, and the best sites were the sites which had sufficient humidity, and these were the forests, because the pastures usually were in quite dry areas. And at that time, or a little bit later, 2000 before Christ, that was when the Bronze Age started. That means first we had the Stone Age. The Stone Age, that was the age which lasted until the Bronze Age began, and it lasted longer than the Pleistocene, longer than the Ice Age. No? So human beings still were dealing with their tools made from stone, and that was just until 4,000 years ago. No? And then the first tools from metals were bronze tools, and therefore the name of Bronze Age appeared. No? 2000 before Christ, 4,000 years ago, more or less, and you can see on this small map there was already population, mainly in the Near East, but also the Balkans, also Italy, North Africa. But at the same time, there was already a huge population developing in East Asia and South Asia. No? So these were the main centers of population when the Bronze Age started. And Bronze Age means metals, and metals mean different kind of technology, which man was able to deal with natural resources. Before it was mainly fire, was one important tool. No? More than 500 years, over 500,000 years of fire management in some way. And gathering and hunting, but then agriculture made its main steps because of domestication and other technologies. That means using the tools. No? This was starting with the Bronze Age. So from the Bronze Age to the modern times, we had lots of land areas which became converted, which no longer were in their pre-human interference shape. No? So forests and also wetlands were shifted into agricultural lands. No? Wetlands mainly by drainage. No? So they opened up canals, no? And lands were drained, and people then had no longer wet feet. They could build their houses better and so on, and also pastures were able to develop better there. And the main centers of civilization were these two, and North America came a little bit later. They had very low, let's say, population density until, let's say until the Middle Ages even. And how that influenced forests, we can see here. So some ideas that in these green areas, most of land cover was characterized by forests. No? So that was more than a third of land surface areas. But now you see some differences here, in Europe mainly, in the east of North America, also in some parts of South America, and around the Congo Basin, and in Southeast Asia, no? So where the main populations were. No? So forest cover now has gone down to, depends on how you count it, maybe 25%. No? So 25% of land cover is still covered with some kinds of forests. And in this industrialization started around 1750, one can say, and lots of things changed there. No? So steam power machines were invented, fossil fuels became used for energy production, from carbon mainly in the beginning, later from petrol, oil, and then later in the 20th century petrochemical products. All these fossil fuels were used to transform the world. And they were replacing mainly one product, and that was wood. Before, wood was the main product to store energy or to be converted into energy, apart from, let's say, small hydropower facilities which people had at their mills and so on. But before, it was mainly wood. And so it was the first choice for fuel, but also raw material for lots of things of utility, even for building houses in many cases, in many cultures. Here you see a picture from the early modern times, late Middle Ages, no? in the northeast of France. No? So you see they were cutting down the forests and they were piling it to convert it into charcoal in this case. No? So they're already around 1550. Yeah, there was a lot of activity going on. And here you can imagine how the forest, which still exists, was already in the mind of the foresters how to use it. No? So you had some old oak trees or lime trees, no? And in the heads of the engineers, they were already converted into materials which they could use to build their fleets or to construct houses or whatever. No? So until industrialization, wood and the forest was in the center of the thinking of the engineers. But wood still has some importance, especially in the poorer regions. Here, this picture is not from Georgia, but I think from Belarus, so it's not so much different. But even in the modernized world, you see that even something so simple as firewood builds a bridge to some luxury items. Here you see the fireplace in modern homes. Wood, yeah. And if we look at Georgia, we can assume that maybe half of Georgia, whatever, was covered by forests during the warm phases of the Ice Age. But there was still some steppe regions which were too dry, and but especially during the warmer phases of this Ice Age, and at the same time during the cold glacial phases, some regions of Georgia, they were acting as a refuge. Species which could no longer thrive under the colder climate conditions. So one can say that maybe sometimes 5, 10 or even 15 degrees colder it has been during the ice ages. And many plant species, they had to ask for asylum in Georgia. They were coming from Central Europe. They also received asylum in the Balkans, and now it's the other way around. And that was happening to the plants. And so we have these forests still there, and when the climate warmed up after the Ice Age, these species spread, but only a few individuals started to spread. So the diversity is still much higher in these refuge areas than in those areas which were newly occupied by some migrants. So one can assume that genetic diversity in the newly occupied areas further north and northwest of Georgia is much smaller than we have here. So it's a resource. So even in these forest lands in eastern Georgia, and this is maybe from western Georgia, this is eastern Georgia, and here you see some areas which maybe have been between forest and non-forest for a long time. Yeah, and if we come to the steppe regions, there were some areas which maybe never have been covered by forests, because during the ice ages it was too cold, and then when trees could grow, the pressure of foraging animals, like not only sheep but mainly donkeys or horses, could have been, let's say, keeping short any intent of the natural vegetation to convert from grasslands into natural forests or shrublands. So that is possible, and there is no big research done about this issue. And yeah, we can say so. We have in Georgia these both systems. No? One is with forest, and the other is without forest naturally. No? And mainly the systems without forest, they were occupied by agricultural systems. And if we take a look at the world in general, what happened to land ecosystems since industrialization after 1750, more or less, you see here the conversion of the natural land cover is underway. This is in North America, and that started quite early. In the 18th, 19th century, it was very intensive, and later, or even from then, it was also beginning in the subtropical and tropical regions. Like this is a picture from Indonesia. That is more recent. But we also have land conversion in the boreal regions. In the taiga forest. Yeah, what we have here now is more or less what we have as a leftover of high forests, dense forests, of evergreen forests and deciduous forests. Deciduous, that means they lose their leaves during the drought season or during winter time when it's too cold. So from this nowadays in some calculations, or you can say that up to 31% is some kind of forest cover or forest land, but only 1/3 of this area is primary forest. That means natural forest without human intervention, only 1/3 of it. 50% is somehow used or managed, and then there's the rest of it, maybe 10 and more percent is severely devastated. And about 10% of this whole area has, in some moment, has been planted. So planted forests are just a minority. In Europe, very frequent. In Georgia, not so frequent. In North America, and in some areas, still frequent. But many forests, they regenerate naturally. That looks like this here. There you have some seedlings on the forest floor, and they are growing up. And a little bit later, if enough light is there, they are growing up to become the new forest. So natural regeneration without human direct planting assistance is the main form of regeneration. And so here we have 40% of the whole area is forest, and only 7 points of this 40% is from planted trees. And if we have a look at the whole picture of the primary forests, that means before the Bronze Age, and at the end of the Stone Age, they are expected to have been covering this area, which is reddish, and the primary forest areas which are still existing are the dark green ones. So even here in Southeast Asia, 20 years ago it was all green, and now half of it is already gone. The same is true for Africa, and in South America the same. So there are some problems that these natural areas are disappearing, and even if it's only a quarter of the global land area, these forest areas are the main home of biodiversity. They house more than half of the animal, birds, and insect species. And also in Georgia, it's the same. If you're looking outside the forest, so the species diversity is not so high. But forests still, for 400 million people, and mostly the world's poorest people, they are providing the main livelihood or the main insurance to survive. No? And even in Georgia, it's more or less the same. No? That we have maybe 5% of the population which are maybe the poorest ones often, and without the forest nearby, they would lose even the small security option which they have by having the forest in their neighborhood. No? So the proportion is more or less the same. No? Yeah, but apart from these biodiversity issues, the importance of forests for livelihoods and for other social purposes, there are also some physical or geochemical aspects, no? For which they play an important role. No? So you see food, fuel, health, shelter, inspiration, yes, inspiration. And these physical and biogeochemical aspects, it's, for example, that they are protecting land surfaces, no? Against soil erosion. They are important for global and local water cycles, or reducing or buffering the impacts of extreme events. No? Like you see here, you see a nice slope which we have on a third of Georgia's forest. They are looking like this. You cannot even climb up because it's too steep. And in the end, they are protecting, let's say, the soil surfaces, you know, against erosion and other things. You know? But sometimes the growing mountains of the Caucasus, even the forests cannot prevent that things like the Vera flood is happening, no? Because these geological processes, they are so strong, and the trees, they are just sitting on top there. And even if you are sitting on top with your roots, if something is happening further down, or if it's overloaded with water, even the forest, the tree roots are not strong enough to keep the soil on the ground. No? Yeah, but there is another aspect in which these forests are important, and yeah, also in our courses we are having a look at it, and where forests are involved quite intensively is this global carbon cycle. No? Maybe you have heard about carbon. No? Carbon is playing an important role in what is happening in the atmosphere of the Earth. No? And forests are strongly involved in uptake and storage of this carbon. And this carbon in the air, it's not carbon, but it has a form of carbon dioxide. No? Because in the atmosphere, usually we have gases, no? Apart from water droplets in the clouds. No? But usually all the rest is gases, and carbon there in the atmosphere is in the form of carbon dioxide. No? And you see some animation picture, no? So you see the cycle. You have radiation, you have photosynthesis there, no? You have uptake of carbon dioxide, and it's building up, for example, wood or other tissues, no? in the vegetation. And when trees die, for example, then this carbon once again is released and is turning back into the atmosphere as carbon dioxide. No? But it can also be buried. No? It can be become part of the forest soil, or it can become part of can be leached as some. It can be leached into groundwater, no? And in former times, this leaching even caused generation of the oil deposits, no? By humic substances, no? Which were leached. Okay, and what these foresters now are looking at is that carbon is the main store of carbon is in wood. So wood is the cheapest and most efficient way to store carbon during a certain time. So the wood can store carbon as long as it exists. If you put it back into your stove and burn it up, then in 2 hours it's gone. But if you store it in a dry place, it can last 1,000 years. Or in a humid place, underwater, where there is no oxygen access, it can even last longer, depending on the conditions. So if you have water with high oxygen amount, so it also will be decomposed. But if you have standing water with no oxygen inside the water, so decomposition almost is stopped. So now we're going to have a look at this carbon cycle, and we have these, not only the growing forests store carbon, but also if you cut the tree and take the wood out, and you have it here, so as long as this desk is not thrown away, it will store the carbon. Or even if you use carbon and use it for heating your home instead of using gas. So wood is from a recycling carbon source, but if you use gas, that's not a resource which can so easily recycle. So let's say the amount of or the possibility to inhibit that fossil fuels are released into the atmosphere. So this potential of wood is also something beneficial to replace other materials or other fuels which are, let's say, changing the balance of the atmospheric gases. And these atmospheric gases, they are called the greenhouse gases. Yeah. So there was another aspect of forests, but then there is also deforestation. Deforestation is, here's a picture from Myanmar. From Myanmar is this picture. So you see,
Burma,
yeah, Burma, former Burma. Yeah, you can find pictures of deforestation from anywhere. So I took this one. You see people still there living in the villages, nearby the forest, but once these forests are burned, under certain climatic conditions, they can recover, like in the temperate forest zone. So it's not so difficult to recover. But in the case of tropical or subtropical forests, it's almost impossible to reconstitute the same forest before with its biodiversity, because once it is burned up and converted into agricultural lands, and then if a politician comes and decides, yeah, we want to have the forest back, it's not so easy. You may plant trees, but you will never get back the ecosystem. So that is a huge problem. In the temperate region, it's more or less possible, even in the boreal zone. So you can clear cut the forest, and if you don't burn it, you can replant it, and after a couple of 100 years, you will have a similar ecosystem as before. But in the tropics, it's a downward spiral. So because biodiversity is getting lost, and that is difficult to recover. And so we have, when the forest is gone, under certain conditions, biodiversity can be affected or severely affected. Like this ape here, he's running around in the lost forest. And a part of these other values, then also we have the problem with the carbon. The carbon, once the trees are taken out or once the trees are burned, and the ground vegetation is burned usually, no? So it's slashed and burned. Once this is gone, then you have also a huge impact on the atmosphere, but because most of it does not go to the rivers, but into the air. And here, for example, is pinned up the history of what has happened in which region of the earth. No? So we had lots of deforestation in the non-tropical regions. They were leading until 1880 certainly, and still until the Second World War. No? But then after the Second World War, we had immense deforestation in tropical Asia, tropical America, and tropical Africa, and deforestation was going down in the developed world, no? But mostly at the expense of these other regions, no? Because the enterprises of the developed world, they were prohibited to continue with deforestation in their countries, so they went and set up their businesses in the underdeveloped world, where they just had to pay some fines or bribes or whatever, and they could continue with their business. So that is where and how deforestation started. But they only took out the cream, let's say, the most valuable trees. No? And once the access was open, then you had lots of huge poor populations, poor farmers who were living in the suburbs of the cities there, which were growing, and they went to colonize these areas, and with no instruments, with no knowledge, with no money. And they were those ones who continued with deforestation. They opened up their lands, and then also came big farmers who wanted to make money with, by growing livestock there. And now most of these regions are occupied by big companies, no? And it's no longer, let's say, the small poor farmers, no? More and more it's a big companies who are governing what is happening there, no? In these regions. And if we look, compare what happened in our atmosphere regarding to carbon dioxide emissions, then we can say that land use, so the sum of agriculture and bad forestry and livestock management, it was as large as all the rest of fossil fuel burning and other industrial emissions like cement production until 1980. So if you, this here is from land use change, and if you sum up this area and compare it with the other area, which is this fossil fuel burning, so 50 by 50% is holding more or less to the 1980s. And then also because less and less land was there to occupy new, to deforest, then the industrial aspects are increasing. So until 1980 it's 50-50, here's 1970. But then industrialization is now putting its print on what is happening in the atmosphere now. And nowadays, deforestation, bad forest management or bad agricultural management is only making up 12.5% of all global carbon emissions. It's still a lot, but because there is not so much easily accessible forest left, it's decreasing its proportion. But if we look at any vegetation or any forest or temperate forest, in the end it's building up so much carbon which later is decomposed when the tree dies, for example, or when the vegetation dies and is decomposed. So it's a cycle. No? So in theory, the net effect is zero, no? Almost zero. No? There are some small effects. Let's say what is stored in the soil. That's a little bit of plus, no? Where the ecosystem is taking up carbon and storing it. No? So usually we have a completed cycle, more or less. But in the case that carbon is not decomposed, there are some cases which I meant before. There's peat formation, for example. No? So in swamps where you have water, there's no oxygen, so plant matter cannot be decomposed so easily. And when time is acting, then coal is formed, for example.
Sorry, ყველას ესმის ფით რა არის შემთხვევაში?
Peat. It's like swamp, it's like dead material in swamps.
I mean, არა ხარ ბიოლოგი. არა, მაშინ იგითხეთ ხოლმე ეგეთი რაღაცა, ტორფია. ტორფი გაგვიყვება.
So, yeah, peat. And then you have maybe, if some tens of millions years pass and this peat is covered by other sediments, for example, then it gets compressed, and then you have the formation of lignite. It's like, in German it's called brown coal. So it's a low quality coal, which is causing a lot of pollution, and they can, in many areas of the world, it's just digged out from nearby the earth surfaces. But it can be used as fossil fuel, lignite, and when it's getting older and older, these old buried plants, or fossilized plants, in the end you can have anthracite, which is the purest carbon. Which is coal from 300, 400, 500 million years ago, from the Carboniferous age. So, and that happens because there is no possibility to decompose it. There is no oxygen there for bacteria to be able to decompose it. So. Only when foresters take out the wood, for example, from the forest before it's getting decomposed, then they can save the carbon from getting decomposed, if it's not converted into peat. So this carbon in the forest, it grows, and if it's taken out, it's a benefit for, let's say, for the current condition of the atmosphere, because it's not released immediately. So the forests are a possibility to store carbon, to take up carbon. There are also intentions to do it in an industrial way, but it's not so easy, it's quite complicated to take out lots of the carbon dioxide which is in the air. So the easiest way is to grow plants like trees, which transform it into wood, and take out the wood and not bring it back into the cycle for some time, as long as you can. Yeah, in furniture or in other things. So that is one effect what forests can do. And you have these products which can be used, and if this product is replacing another product which is made from, let's say, from aluminium, which requires a huge amount of fossil fuel or a huge amount of energy to be produced. The same desk made from aluminium, maybe it has a 10 times higher release of carbon into the atmosphere than producing this. So it's not only the wood itself, but it's also replacing other materials. Okay. And there is another form to store carbon. So one form is the natural form, that it is stored naturally under restriction of oxygen than in the tree, but it can be also in the soil as humus or stable humus compounds. So these three processes are happening in nature, let's say, natural ecosystems. So all this carbon which is now emitted into the atmosphere, this is the upper part of the graph, or all the carbon which is released, fossil fuels and cement, land use change. So we are now at this magnitude, 10 gigatons per year, and this carbon has to go somewhere. So it either goes into the atmosphere, that's the easiest way, this one, this light blue part, or it's taken up by the oceans. The oceans can take up lots of carbon. Carbon dioxide, for example, is needed by all the algae, which are distributed all across the oceans, which feed the chain of marine life, you can say, and can also be taken up by land. That means by ecosystems. And it's mainly the forest. 2/3 of it is taken up by the forest. So we have the sources of carbon, and down here we have the sinks of carbon. And it's not only the atmosphere. So also a huge part is going to the oceans and into land ecosystems. And the problem what we have with climate warming, global warming, is what happens in the atmosphere. In the oceans we don't even know what is happening, but there are also processes going on which we don't like. And from all these land ecosystems where we are living now, it's mostly the forests which can make a positive impact, because they can store and take up, or they can take up more carbon than all the other systems together, like savanna, grasslands, wetlands, agro-ecosystems, and deserts. Yeah, and these two moves, they are discussing if it was so intelligent to cut down the trees in order to make it not so easy for the hunters to hide themselves. So that was just a small break for you. Okay, this is a map of the forest-covered area in green once again, and the red spots are these areas where highest deforestation is going on. So here in the taiga regions and Southeast Asia, around the Congo Basin or in the Amazon and so on. And there are some countries, the green ones, which in the last 10 years they reforested more than they have lost. But the main region where afforestation is taking place is in China. So there was a huge effort since the Mao time, but they are not really reforesting ecosystems. They are just planting wood. Let's say it's not nothing to be proud of as an ecologist. So it's not really an ecosystem. Meanwhile, in most of the other areas, there are some forests which are close to nature. You can say, okay, they are ecosystems. Yeah, and one might think that to stop deforestation would be one important thing to do against climate change or global warming, and that is like this. But when we look only at Georgia, country, and if you see how some trees are planted and then they are just right away burned or they are not taken care of, you realize that's a long way to get there, no? To make replanting effective, no? That's not so easy. If the culture does not fit, or if the proper care is not taken, no? So it's much easier to protect from deforestation than to reforest, no? Yeah. And if we look at education, let's say on what we are doing in our courses, this semester we made one small step, no? And we were looking at this, how much carbon is there in these ecosystems, no? And we try to assess it, no? And, to assess it, no? And we try to look at the carbon storage, no? Now here you see some ecosystems. There is an ecosystem which is quite with dying trees, no? It's also near, just around the corner from Tbilisi, so it's critical there, and here it's not so critical. And to increase carbon storage or to maintain carbon storage, to maintain forests is even now an issue within this next Paris conference, which is taking place the next week or at the end of the month, no? And they want to create lots of money, lots of funds in order to prevent forests in poor countries, for example, to disappear, no? But that will be a little bit tricky. But the interest is there, and the first step, what is done there, is to find out how to inventory these forests and how to inventory carbon. No? How much carbon is there, and what is happening if some kind of management is happening. So let's think of the forests. They are growing or they are producing wood. For example, if you just look at the merchantable wood, no? It's here on the poor soils or poor areas of Tbilisi, it may be 100 grams of carbon per square meter every year. No? Maybe at the other end, in Western Georgia, maybe you have 600 grams, no? Or 500 grams of carbon per square meter and year. No? So it is somehow remarkable. No? So here carbon dioxide is coming in, it's stored in the wood. Sometimes it's stored in the soil, a small amount, or it's running off with groundwater, but the rest is circulating. But if you look at 100 grams of carbon per square meter and year, that is the same amount which you are burning when you are driving a car for 1 kilometer. No? Yeah, depending on how clean the car is, and if it's quite clean, maybe only 50 grams. And if you put 6 persons in, then it's per person only less than 10 grams per carbon and person. No? But the 100 grams per 1 kilometer of driving is going out of by driving a car. No? So to share the car or to use a bus, better is to go on foot. Even a plane is better than an airplane, has a better balance than driving a car. 100 grams, and that is what is net stored in merchantable wood on 1 square meter in the forest. No? So we are doing, or what is happening in the towns is quite a lot. No? And what the foresters can do is they can try to manage it a little bit. And so we already said that if we are replacing fossil fuel-based energy or fossil fuel-based materials by wood, then we can even increase the benefit of what wood is providing. Here is this is the amount of years, so 10, 20, 30, 40, 50 or whatever years is growing up in the forest. And if you do some thinnings, take out some trees, then part of it can be used as a wood product, which stays for a longer time, but then you have lots of residues also, which once again are decomposed. But if you use these residues to produce energy in your forest, in your sawmill, what is often done now, so you replace fossil fuels, so it's quite a benefit. And if you look at all of these replacement potentials, so it's not only the wood which is growing in the forest, but there can be 2, 3, 4 times higher secondary benefits if you use these products from nature. Yeah, and so we can build up, let's say, 100 grams per year, or 3, 4, 500 to be taken out. And at the same time, what is happening in the soil is quite small. It's only 1 to 5 grams per square meter. But if you look at the geological time scale, it can be quite a lot. You just count 10,000 years since the last ice age. 10,000 times 1 gram is quite a lot. So we have already 10 kilograms in the soil. And sometimes soils are millions of years old. And so far, if you look at the foresters, they are more looking at wood volumes, what can be sold, and so on. But now they are already started to look at other benefits, the social benefits, ecological benefits, and they are looking also at diversity. So they want to have a production forest, but in Germany now they are also even counting the dead wood in the forest, and they know that the dead wood, a certain amount of dead wood, is habitat for decomposers. So we increase strongly our biodiversity, species diversity, because many are those species in extinction or species which are threatened, which were participating in the process of decomposition, in the natural recycling process. And now the foresters are starting to take care that there on every 100 meters there must be one dead tree standing there, just for creating a habitat, or a certain amount of dead lime trees, even in the regular forestry management, under regular forestry management. So foresters are changing. Here you see another forest which is even denser packed with dead trees, but this is more a system which is rather a nature protection forest. And then you have also the other function, which is the social function, which is more looking at recreation and other social issues, where forests can play a role. So thinking of all these different issues now, starting from carbon and social issues, and not just looking at production. We are now taking more a multidisciplinary look at these different subjects we are studying. So we are no longer making just taxation of something, but more into detail. And you see what everybody's on the pictures. So we are looking at ecological diversity, but also at the economic potential and the functions for society. And on the other hand, what this has to do with global change and the carbon cycle. So as it is becoming an important issue, we just managed to change our forest taxation course, or forest survey or forest inventory course, into something which is covering more issues. No? So this forest resources assessment, now we are also trying to assess carbon. No? So what did we do? It was just 3 weeks ago. There is one participant. So we established a sampling plot of 500 square meters, and then we identified all the trees, for example, and woody shrubs there. Everything which is woody, because only what is woody is interesting for storing carbon. And then we measured and calculated the volume, and from the volume, the biomass per each species, because the density of wood volume is different between the species. And from there, we derived the carbon contents. And then, one by one, we did this, and we did it above ground. And below ground also, of the vegetation, of the merchantable and the other sizes which are not commercial. So we included branch wood, stump and root systems, and some of them we can measure directly, and other we have to use some approximation factors which are not so satisfying. So for example, we found out that we had on this plot something like 4.5 kilograms of carbon per square meter in merchantable wood. That means every wood which is bigger than 7 centimeters in diameter. And a similar amount is stored in all the branches and leaves and in the stump and in the roots. It's almost the same amount in our forest plot which we had. If the forest would have been older or bigger, huger, the proportion of this is higher. But in this case, it was almost the same. And then we also measured carbon in dead wood. So we also measured the size, standing and lying dead wood. And then we even measured what is in the organic humus layer, that means on the forest floor, on top of the soil. And we found out that there we had, because it was quite thin and it was only 600 grams of carbon per square meter. And then we also had, we made an estimate on carbon in the soil microflora and fauna. So there are not so many resources in literature where you can look at, but we had a certain range, and we picked the upper end, not the extreme, but the upper end of the range, and so we came to 150 grams of soil microflora and fauna. Then we started to estimate the carbon contents in the mineral soil, and we did not have a lab, but we used the soil borer, and we looked at the different properties for each depth. And then we compared it with similar soils from literature. So we had some literature with lots of analysis, and we found out, oh, this soil is closest to this one or in between these two. And then we looked up and checked for carbon contents in these other soils, step by step, down to 80 centimeters. And then we came to a total of 15 kilograms per square meter, which is quite high compared to 11 kilograms in the vegetation, in the above and below ground vegetation. So 27 kilograms per square meter. So it was at least interesting to make an intent how to get there. And if we look at maps of the net annual primary productivity, what we can find here in the drier areas of Georgia, no? So it may be between 200 and 400 grams per square meter and year. No? And if we compare it with the age, for example, of the trees and so on, it may more or less fit. No? And if we look at the soil and we say, okay, this soil maybe was not so old because it was from slope erosion possibly, no? But it had quite high carbon amounts in the topsoil, no? And if you look at 3,000 years and how much is accumulated there, it also fits more or less. No? Yeah, now coming to the end, we had some conclusions, or one thing is that things which you cannot directly measure, that's always difficult when you have to use factors, and there's not so much known about it, so it's not so satisfactory, you know, just to use these expansion factors for something which you cannot really see. Yeah, and maybe one could use some kind of lab analysis, because carbon is almost a simple thing which could exist, but it's not possible. And that it is a possibility to do it like this assessment step by step, and comparing it with literature, like other assessments are often done, because they are also, assessments are often not measurements, because in measurements you are using lab facilities, which we don't have or we don't need, because it's more practicing or doing something practical and finding out what is around us. No? Yeah, and if we look more at the implications of what we have seen, no? If you look at forestry, no? Even if one would, it would be a nice thing to have the opportunity to create jobs with forestry, and it is quite realistic. But now it's not happening now. But if one would do it, no? If there would be more, let's say, management for using these resources which are growing and decomposing without, let's say, proper attention, or there is no big value created, no? But one job per square kilometer could be quite a possibility, no? And at the same time, if you are more active involved, then you can also take care of more carbon uptake in forests and storage, and use it for, for human purposes, no? And to bring it to the market, and without interfering with the natural cycles of the ecosystems, no? So what we have now, if we look in Georgia, we have easily the not so strongly growing areas. You have easily 100 tons of carbon per square kilometer is growing there, and in some more productive sites it can be 2 or 3 times more, at least 1.5 million tons of carbon countrywide. And then one can compare it with the compensation schemes, no, which are in this red plus process. I don't know if Georgia will be involved, no, but if one takes care of it, no, there could be a possibility, no? Just by doing something and managing it. No? And appropriate management can be done without cutting down the forests. We can do it intelligently, we can even create more biodiversity. You can create more productive trees on one side, and on the other side you can also take care of biodiversity, no? Creating or leaving niches for species. And at the same time, you will even create income, no? If the bureaucracy is appropriate for it. No? If you have a bureaucracy which is not tailored to create income, at least from some forest areas, yeah, you cannot do nothing in the end. No? But maybe Georgia does not have the choice if it does not want to stay poor, no? So something has to be done. Yeah, and this was just something what we have been doing. And we come to the end. So that's all.
Did I understood correctly that with the knowledge of a carbon deposited annually in a square meter of soil and consistence of carbon, you can calculate the time of a continuous presence of forest in a certain area?
Of vegetation. You have
Yeah.
in agricultural soils or steppe soils.
Yeah, well, I mean in a forest. Huh?
Forest.
Yeah. I mean in a forest. Well, it is like, for me it's interesting because I will explain. Yeah. I am interested where this forest refugia in glacial time, and actually there are some areas where forest was expanded after like last 15,000 years in Holocene, and there are still areas in western Georgia here and there. The exact position we don't know, which are supposed to survive the Pleistocene, the last Pleistocene cycle. Yeah. And should you expect that in these refugial areas you will have many times more consumption of carbon in soil?
Storage, yeah.
Yeah.
Storage.
Yeah?
Yeah, yeah.
So you can actually just experimentally find this out, or?
Yeah, it's possible. Usually you one is counting from a soil with 0 carbon is often a soil which comes from a fresh erosion or from a retreating glacier.
Okay. Yeah.
So they count from 0 and start looking how much carbon is storing there in the soil. No?
Right.
But on the other hand, if you have a soil which was always covered by forests, often you cannot say how long it was. You can just see a recent process, maybe which is 10 or 15 or 30,000 years old.
Okay.
But those ones which were older.
Okay, well, 30,000, you can differentiate between, let us say, 10,000 years old and 30,000 years old forest. This is critical because if you take an LGM, last glacial maximum, this is between 19 and like 25,000 years ago.
Yeah. Yeah. If you really go to the specifics, then maybe by carbon marking, how old is the carbon?
Yeah, well, this
is one, but
not by carbon consumption.
No, but just by saying how much carbon is there, you can say, okay, here there is so much carbon. Yeah, it must have been older, but you cannot really specify it. It's too.
Yeah. questions? One, two.
How can you calculate carbon density? Have you any tools or?
In plants, that's known. For example, in wood, you have the density of wood. You have, let's say, 1 cubic centimeter of wood. There are some lighter wood species like pinus, which has only a wood density of 45, let's say, 0.45. And there are others which are denser, let's say quercus, it's like oak, oak. It's like 0.65. And that's a biomass density. And then the carbon density, half of the biomass, it's almost exactly 50% is carbon. So one can calculate this, but what we are doing is we are measuring outside in the living tree, and then the calculation is a little bit different because the densities are based on dry samples and dry volumes. So we are doing the carbon on the fresh volume. So it's a little bit different. But then it's different for each species. So in the end you have of 1 cubic centimeter of pine wood, there is 0.2 grams of carbon in it, in the fresh wood.
Next question.
Yes. Hello. Sorry. Hello. My name is Becca Zarnaze, and I'm a student. I study international relationships, and I have 2 questions to you. First of all, I want to know what did Jean-Baptiste Goldberry, do you know this man?
No.
Okay. Adam Smith, do you know?
What?
Adam Smith.
Adam Smith, yeah.
What did Adam Smith thought about deforestation, and what did he say about, well, if it...
Tell me what he said. I don't remember. I have not read his... I just know that he was sitting there on the Thames River and was looking by the ships coming by, and then he was thinking what is happening in the world around and how important trade and so on is. But I don't know what he thought about forests, or about what did you say?
Well, once he said the main mission of the country is to make people as happy as he can.
Happy?
As it can, yes. To make people as wealthy as it can, I mean country. So, if we try to plant trees, for example in Georgia, and if we try to sell it to get more money, how can we do this, and where can we sell our trees?
Oh, it's not so. It's not. What we are proposing is not that you need to plant trees; they are growing by themselves. You just let them grow. But there are markets. There are markets to sell wood. That's not a problem, no? Because there is also an illegal market of wood, and where there is an illegal market, also a legal market could exist. No? So markets exist everywhere. Chinese are buying wood from here, Turkey, and that's not the problem. The problem is to grow and administer a product which the market can use, or even the local people can use. No? And for the local people, it's not easy to use it, no? Because there is a lot of tradition, and yeah, it's not an easily accessible good. No? It's not like buying bread on the corner. It's much more complicated.
Yes.
So it just must be made more simple. No? But the main problem is that it is depending on an administration, which is still managed in, not effectively, let's say.
Can I have one question? One more
Yeah.
question, please?
Yeah.
Yes, okay. I have one question. Two questions. First of all, where are you from?
Germany.
Germany. And so, okay. Germany after First World War tried to make country as wealthy as again. Well, I mean, it was economical crisis in Germany in 1929, 1933.
Worldwide crisis, but also in Germany. Yeah.
Yes. Also, there was economical crisis in 1937 and 1938.
What?
Economical crisis, second economical crisis in 1933, 1977, 1978. And Hitler, when he came in the government in 1936,
Earlier.
1933,
Yeah.
he tried to give all the woods to the richest people of the country.
He tried to.
To give all the wood of the country to the richest people of the country to make new establishments to sell this wood.
Hitler.
What do you think about that?
I don't know the details about what he was thinking about wood. I only know that the Hitler government had their internal ideas what to do and what their goals, no? And that was usually not discussed in public. No? So they went on to they prepared for a war, and nobody knew really that they were preparing for a war.
No. I mean, United States of America knew in 1933 already, and so they said that we are neutrals. Also England knows that, and also France knows that. Marshal Foch said that Germany will start war in 20 years. He said this in 1999 in Paris.
Yeah.
Everybody knew that Germany would start the Second World War in 1919.
Yeah. Does it deal with wood somehow?
No, I just.
They are
I just
going.
want to know what Hitler thought, or what Hitler thought about wood.
I don't know.
I think you were planning to make maybe scars from wood to use them in the war.
No, it was not. It was not a special aspect of their policies. To look at wood, let's say. No? They like forests and all these, let's say, traditions which were behind nature ideologies, and so they used it. No? They were even involved with this stuff. No? And therefore, the forestry people were not looked at quite positively during a long time, no? Even after the war, no? Because they were quite, like in Georgia, no? They were quite involved in the establishment. No? So, and foresters in Europe always were seen as part of the governing system, and they were always seen as against the people, because the people always wanted the resource, but the foresters were the people who were forbidding them to have access to this resource, because it was in the interest of the governing groups, no? To keep the common people out, no? Because they wanted the forest as a resource for recreation, for anything, no? But they did not want to have common people participate. But that's history. No? Now forest policy, at least in developed countries, is different. No? So it's more participatory. No? That it's a forest for everybody, even if it's a private forest. No? So in Central Europe, no forest owner can prohibit you to not use the forest for recreation. So it's open, you know.
I had also a sort of economic question, Joachim. Did you ever estimate very approximately, you know, if like Georgia, yes, would use its wood resources really for export or for using and so on? How big percent of a approximate national GDP, yeah, total product can come from selling wood under condition the use of wood is sustainable? You never had any just rough evaluation?
I think it can be approximately like other countries like Austria in percentage, no?
Yeah.
But I don't know how much their percentage is, and there is one direct effect of just selling wood, and the other effects are all the indirect effects, no? Like on tourism and whatever.
Yeah,
no?
but I mean just a direct effect with just the effect of selling timber.
The thing is, even if you would do it now, the wood which is growing in the forest of Georgia, 80% does not have the quality.
Yeah, that's right.
Because
That's why I was asking.
It's growing wild. You cannot use it. Most of the wood you cannot use for specific purposes. So you will just get quite a cheap price, no? And
so
not much higher than
how many? 1%, 0.1%.
One can calculate how much it is, no? So if you have 2 million hectare, 2 million cubic meters, 2 million.
I'm not sure what is the GDP in Georgia, no? Like
it's not more than
maybe 8 billion.
It's not more than 2, 3, 4, 500 million lari per year.
Yeah.
The income from wood, no? Let's say 500 million lari, no?
So which is very little, which is one.
It's not more than
thousandth part of.
It's,
or even less.
In the state it is now. No? If it would be of high quality, it can be 2, 3 times.
So
higher.
is it worth at all just to use timber for cutting? No, it's like in this case, you know, it's very, very little input into a country's economy. Maybe just preserve the forests.
No, the thing is, if you look at for export is one kind of looking. The other way is how many jobs you create locally. Yeah. If it is just done for local purposes, let's say for.
So how many jobs you potentially?
Well, I said there, for example, at least one job per square kilometer, no? So it one job per 100 hectare. So it's like 15,000 jobs. No, it's not so much, no?
Yeah.
It's not so much, but if you look, if it's 15,000 jobs in the poorest village of Georgia, it's 5 jobs per village, and that is already in Georgia. It's a huge impact to have 5 families with a regular income.
Right.
In other countries, it's nothing, huh? But if you look from this point of view, it has a high impact, but on the total economy, not.
But on a
poverty,
social issue, more
social and poverty alleviation, it can have a huge impact because you really pick the most remote.
Understand?
Therefore, it's
now it's like, you know, it's my impression is that a lot of people living here, maybe 10% or I don't know 5% of the entire population, are somehow using forest for firewood and so on, but this is a very little part of their income, but they still are keeping using, so it's more damage than a benefit from this.
Yeah, it depends on.
I don't know.
It depends on how you do it, no?
Yeah.
But it's more to look at strategically. So not just these 5 families per village. If you look at the villages, how they are in Georgia, it's it's a huge impact. It's maybe a higher impact than
Okay.
than other sectors in this context.
Thank you. Dear students?
No more questions.
No more.
I have
One more question. Yeah.
One more question.
sorry about my everything. Well, I have one question about your personality.
My personality.
Yes.
Yeah,
What do you
different
think?
from yours.
Yes, you can ask me any questions. I said, what do you think? What does Germany think about United States of America today?
What does
Germany think about United States of America today? And what does Germany think about France today?
about the USA? It has nothing to do with this session, but
Yes, I
that
know.
depends on the people you ask. Nah. So, a majority of the young population or the middle-aged population of Germany is not very keen on the United States of America. They don't see them as a big example, not just it's more a big neighbor, not more. In France, what do they think of France? In history, it was a main competitor, no? But now that it's gone, that's over. That's 50 years past. It's no longer a question. There is no competition with or no bad thinking about France. Maybe about Britain, that they are so stupid to not to see themselves as Europeans, no? But always something separate. No? But there is no
Okay,
problem.
Joachim, thank you.